Astronomers have observed bizarre phenomena, and no, it is not the usual stars colliding and exploding. Scientists have discovered two identical bizarre-looking objects through NASA's Hubble Space Telescope. It took them several years to identify what these objects are. So keep watching to know the answers to millions of questions in your head. What was seen? A pair of galactic bulges, a galaxy's core star-filled hub, and at least three roughly parallel split streaks make up the strange objects. Hamilton accidentally discovered them while using Hubble to examine a group of quasars, the blazing centers of active galaxies. Under Richard Griffiths of the University of Hawaii in Hilo, Hamilton and the expanding team finally put all the pieces together to unravel a puzzle after pursuing fruitless possibilities, asking for peer assistance, and performing a lot of head-scratching. The linear objects were stretched representations of a far-off galaxy, more than 11 billion light-years away, that had undergone gravitational lensing. Furthermore, they seemed to be mirror images of one another. The researchers revealed that gravitational lensing, a phenomenon that warps space and enlarges, brightens, and stretches the picture of a distant galaxy behind it, was occurring as a result of the powerful gravity of an intervening, uncatalogued foreground cluster of galaxies. This object was particularly puzzling, even though Hubble surveys have found many examples of these funhouse mirror aberrations brought on by gravitational lensing. Here, a background galaxy and a foreground galaxy cluster precisely align to give twin enlarged images of the same distant galaxy. The background galaxy crosses a ripple in space, causing this unusual effect. Due to the gravity of dense concentrations of dark matter, the invisible glue that accounts for most of the universe's mass, this ripple is an area of maximum magnification. Two mirror images and a third picture that can be seen off to the side are created as light from the distant galaxy passes through the cluster along this ripple. The ripple substantially enlarges and distorts the light from the background galaxy traveling through the cluster in the gravitationally lensed distant galaxy. The ripple creates two copies by acting as an erroneous curved mirror, finding the answer. But when Hamilton first observed the peculiar linear characteristics in 2013, this uncommon phenomenon was not widely acknowledged. The image with the mirrored images and parallel streaks jumped out when he browsed the quasar photographs. Hamilton and the other team members had never seen anything like it, so Hamilton and the group set out to unravel the riddle behind these alluring straight lines, later known as Hamilton's object, in honor of their discoverer. At astronomy conferences, they displayed the peculiar sight to peers, who responded in various ways, from planetary nebulas to cosmic strings. But when Hamilton showed the image to Griffiths at a NASA meeting in 2015, he offered the most logical explanation, despite not being a part of the original team. It was a magnified and distorted image brought about by a lensing phenomenon like those observed in Hubble photographs of other enormous galaxy clusters that amplify images of far distant galaxies. Griffiths corroborated this theory when he discovered a comparable linear object during one of Hubble's deep cluster investigations. But the researchers were still facing a challenge. They were unable to recognize the lensing cluster. Normally, astronomers who study galaxy clusters first locate the enlarged pictures of distant galaxies within the cluster after identifying the foreground cluster that is causing the lensing. A galaxy cluster was located in the same region as the enlarged photos in the Sloan Digital Sky Survey photographs, but it was not seen in any documented survey. However, Griffiths was able to determine that the cluster was the source of the lensed images because the odd images were located at its core. The next step for the researchers was to determine whether the three lensed images were all distorted representations of the same distant galaxy because they were all at the same distance. The lensed images were confirmed to be from a galaxy more than 11 billion light-years away by spectroscopic measurements made at the Hawaii-based Gemini and W.M. Keck observatories. A reconstruction of the third lensed image suggests that the distant galaxy is an edge-on-board spiral with active, clumpy star formation. Sloan data were used by a different team of researchers in Chicago to find the cluster and determine its distance at the same time Griffiths and the Hilo undergraduates made their spectroscopic observations. More than 7 billion light-years away, the cluster is located. But Griffith's team was still having trouble figuring out what to make of these peculiar lensing shapes because they had so little knowledge about the cluster. Identifying the invisible. At that point, Griffiths contacted Jenny Wagner of the University of Heidelberg in Germany, a specialist in gravitational lensing theory. With his former student Nicholas Tesor, who is currently at the University of Manchester in England, Wagner has examined related artifacts and created computer tools for analyzing unusual lenses like this one. The team's algorithms assisted in determining how all three lens photos were created. They concluded that the dark matter must be smoothly spread at small scales in space around the stretched images. Nearly a century after its discovery, astronomers still don't fully understand what dark matter is, so this result is significant, according to Griffiths. Let us know your thoughts in the comments. Make sure to like and subscribe to never miss an update. Thanks for watching.